Hi, guys. Okay, so let's look at chapter 13, exercise problems. That is a chapter on solutions. And this is the introductory chemistry textbook by Tro, available on the Libre text. So we are going to use these problems that are listed at the Libre text website. So the problem 13.2.1, this is related to the solution is made by dissolving 333 grams of HCl in 40.0 grams of methanol, CH3OH. So if you don't know the names, it's okay for Chem 38 or Chem 192 or, Chem 006 or any of the initial classes. If you don't know names of any, or, we're not expecting you basically, but we are trying to introduce you to organic chemistry. That is why we show you these type of, like molecules. And these are basically carbon, hydrogen, oxygen makes organic compounds. So you have dissolved 3.33 grams of HCl in 40.0 grams of this thing is called methanol, methyl alcohol. So identify what is a solvent and what is a solute. Now keep this in mind that the solute is always going to be in small amount. So 3.33 is small amount in comparison to a larger amount of 40.06 grams. So anything that is in a large amount, so solvent is always going to be in a larger amount. And the solute is always going to be in a smaller amount. So smaller amount of solute is the HCl. As you can see, it's only 3.33 grams. So very less amount in comparison to the larger amount of, this is the methyl alcohol, CH3OH, methanol, and this is 40.0 grams. All right. So these are the way to identify the solute and solvent, and don't worry about the names that they give you. So if the names are like weird, just focus on the amount. Okay, amount. Which one is larger and which one is smaller? Larger versus the smaller. Okay. Similarly here. Now we are given another question in which you are given, this is the C3H7OH. Don't worry about the name. Just take it as this is some kind of organic molecule. Okay. CCl4. Again, this is a kind of organic molecule. Water is H2O. Now, what do you know? Just looking at these molecules, what do you know about them? If you look at it, CCl4 is made up of 1 carbon and 4 chlorines. So you must have seen it. We made the Lewis structures of this. So this is CCl4, looks like that. Okay. And then water is this. Now, there is a very unique difference between these two. Water is polar. All right. Water is polar. And water has hydrogen bonding. Why does water have hydrogen bonding? Hydrogen bonding because of the presence of OH. Okay. Now, in this molecule, C3H7OH. Right? Now, C3H7OH, this OH alone should tell you that there is hydrogen bonding occurring, or the possibility of hydrogen bonding here. So this OH bond is common to water, and so this will cause hydrogen bonding. So hydrogen bonding here and hydrogen bonding in water also. Okay, so both of them are polar. So let's put it here. So this is also, water will also have hydrogen bonding. And why is there a hydrogen bonding in water? Because of the presence of the OH group, this OH group, OH. Okay, and then here you have this OH. So OH, because of the presence of OH, and here is also OH is present. So because of that, there is a hydrogen bonding. So learn about the hydrogen bonding in the intermolecular, chapter. We did that earlier. So you should know that. And the next thing is that what about the CCl4? This one is in non-polar. This is non-polar, even though it has the 4 chlorines, very polar, but there is a equal pull from all the 4 sides. Therefore, this becomes a non-polar molecule. No hydrogen bonding is present. That's one piece. Next thing is that this is polar. So polar and polar will always mix because of this OH group. The polarity is going to be towards the OH side. Okay, so polarity is here. This is polar, and hydrogen bond is also polar. So which ones are going to mix? So we will see that you're going to say that C3H7OH are both polar and polar, like is and water are both polar and polar. Therefore, they are going to be soluble. So this is going to mix together, or C3H7OH is going to be soluble in water. Okay. Now, next is the toluene. Now, toluene is all of them. Look at this. All of them are these guys are carbon hydrogen bonds. So anytime you have lots of CH bonds, no matter what, this is always going to be non-polar. Okay, so non-polar and non-polar are going to mix, like dissolves like. Polar and polar mix. So let me put this rule here. This is based on like dissolves like dissolves like. So when like and like mix, then they are polar. Polar and polar will mix, non-polar and non-polar mix. So in other words, now we are going to look at which one is non-polar out of here. Water is polar. So here, so water is polar. Water is a polar solvent. Always, that's by default. Okay. Sodium sulfate, this is an ionic compound. It's made up of a metal and a polyatomic ion. Okay, so this is an ionic solid, ionic compound. Okay, sodium with a sulfate is metal with a polyatomic ion. So this is a metal with a polyatomic ion. So metal with polyatomic ion, ionic solid, and toluene is a non-polar. It's a liquid actually. So toluene will not mix with. So like I said, that the polar, non-polar and non-polar will mix. Non-polar and non-polar will mix. So we are going to identify which ones are non-polar now. So obviously water is polar, will not mix in this case with water. So water is polar, will not mix. That is an ionic solid, will not mix. So this guy C3H18 is non-polar. So toluene and C3H18 are going to mix. Okay, so will non-polar, this will mix or will be soluble with will mix with toluene, with C6, H5, CH3. Okay. All right. Next is which compound will dissolve in solution which compound will dissolve in solution to separate in ions. So in other words, will break up into ions. So remember that anytime you have C3H10O6 like that, again, this is an organic compound. So organic compound, and it's an organic molecule, will not ionize. So anytime you have anything which is C6H12 or like, or COHNO, these guys, organic molecules, CH, and whatever, oxygen, nitrogen, you can have any, or chlorine or whatever, right? All those. And so how do I put this here? 1 second. So CH, whatever, this side will never, organic molecules will not ionize. CCl4 also is an organic molecule. Okay, organic, because chlorine is bound to carbon. So it is an organic molecule. So this is also will not ionize. Okay, next is the carbon tetrachloride, calcium chloride. So calcium will give you +2 sign, +2 charge, and chlorines -1 charge. Here, silver will break up into silver +1 charge and nitrate into -1 charge. So which compound will dissolve? So so basically, we will see here that the calcium chloride will dissolve in water, but sparingly soluble. Okay, silver nitrate will dissolve completely. So here, let me put this here. This one will dissolve fully. Okay, but calcium is partially soluble. So this is sparingly soluble. Remember that Castro bar, but this is completely soluble. Okay, let me move this a little bit here. Partially soluble is this. And this is the other one is completely soluble. Okay. Now we have How do you know? So you come here and you go back to your solubility table. And if you look in the solubility table, as I mentioned already, that all chlorides are soluble in water, except, you see here, chloride, bromide, iodides. So here you have, in this table, it's not listed, but chloride, bromides, iodides. So this is still, because it's a Castro bar, lead, mercury, silver, chloride, bromide, iodides, I know is still, these are, it could be sparingly soluble, calcium chloride, because fluoride, calcium, barium, strontium, calcium, lead, and mercury, fluorides are sparingly soluble. Chloride, bromide, iodides are also sparingly soluble. Okay, so keep that in mind. But it could also be fully soluble if, it depends. You can increase the temperature. You can add more of the solvent, and so, it can dissolve. Okay, next this is a question of the Henry's law. And I did not cover Henry's law to depth in the lecture, so I'm going to just cover it quickly here. So what is the Henry's law? First of all, Henry's law is that the gases, they dissolve in water, right? But to what extent they dissolve in water, or how much, how do we know? If you put a lot of pressure inside the water or any liquid or any solvent, the gases can be forced to dissolve in at a low temperature in the liquid solvents, right? Or the other thing is, the Henry law talks about the concentration of the gas dissolved inside the liquid is directly proportional to the partial pressure of that gas above the liquid at a constant temperature. So in other words, what they're saying is that if you have a gas, let's say this is a gas in a container, and there is a, let's say you have like a Coke bottle, right? And it's been kept on the table for some time. So there is some carbon dioxide inside it, right? Dissolved inside it. And some of the carbon dioxide is going to leave and come on top. So this becomes like a little partial pressure or the vapor pressure of the gas. So the amount of gas that is present inside, it's all about equilibrium in the end. So the amount of gas that is dissolved inside the liquid, this is the gas that is dissolved inside the liquid, this gas, and the partial pressure of this gas is the same. So this partial pressure of this gas and the gas that is dissolved, the concentration of the gas, there is a relationship. P stands for that partial pressure and C stands for the concentration. Okay, P is equal to partial pressure. Why is it partial pressure? Because there's, if it's an open system, there's an atmospheric pressure also. So, or it's a vapor pressure of this gas. So not really the vapor pressure, but it's called a partial pressure. So partial pressure of this gas, and the C stands for the concentration of the gas, which is inside. So the concentration or the amount of gas that is present inside the liquid and the amount of gas exerting its pressure outside the liquid is same, is directly proportional, is related to each other. And so what is that relationship? How are they? It's constant. In other words, K stands for that constant, and K stands for the nature of the solute and the solvent. So K is defined by, like, what kind of gas are we dissolving? So K, it depends on the solute, the type of gas, and it also depends on the solvent. So it depends on that also. Some gases could be readily soluble or not. So its units are moles per liter times, the atmospheric, the unit of pressure bar. Okay, so here in this case, concentration is directly proportional to the pressure of the gas. Okay, so in other words, in general terms, the more pressure you put in a system, the more it is going to be dissolved, So this also means that. But Henry's law is about, the partial pressure on the top of the liquid or the solvent, and the concentration of the gas inside the liquid or the solvent. Okay, so that is given to us. The partial pressure is 152. Okay, the partial pressure given is 152 torr. And when the partial pressure is increased, then it becomes 760 torr. So when the partial pressure was 152 torrs, then the concentration of the gas was 1.45 into 10 to the power minus 3. But when the pressure was increased. So what happened to the solubility, or what happened to the concentration of that gas? So find that. So here, the formula, which is not given in the book, but you should, know that this formula is C1 over P1 is equal to C2 over P2. What is C1? C1 is the initial pressure, initial concentration when the pressure is given. So here's this solution. C1 is 1.45 10 to the power minus 3 grams, and pressure at that time was 152 torr. So we are being asked to find what is the concentration when the pressure becomes 760 torr. So when you get that, then you get this answer, 7.25 into 10 to the power minus 3. So you see, as the pressure is increasing, so if you look at the numbers here, 760 torr, 152 torr, 145, and 7.25. So as the pressure, when the pressure was low, the concentration was low. When the pressure increased, the concentration increased, or when the pressure increased, when the concentration increased, the partial pressure also increased, the other way around. Okay, now let's look at the next problem, which is the problem on just give me 1 second, I need to put my charger. All right, so now we are looking at the units of the concentration, mass by mass percent. In other words, the mass of the solute. So remember always that the solute is always going to be in the small amount plus the amount of solvent. When you add the two together, then they make the solution. Okay, so if you are given the grams of the solute and the grams of the solvent, they are added together to give you the grams of, so the grams of the solute, the grams of the solvent are added together to give you the grams of the solution. So read very carefully. Read. In this case, it's very important to read carefully. Is the question talking about the solvent, or is the question talking about the solute, or is it talking about the solution? So in this case, we are given the grams of the solution. That means the weight of the solute has already been added. Okay, so here we are going to write down the formula is what is the mass by mass percent. Mass by mass percent, how you do it? The mass of the solute in grams, right, over the mass of the solution, not the solvent, of the solution in grams times 100%. Okay, so what do you get here? Mass of the solute is 2.00. No, sorry, is 15.8 grams of some substance, grams. Okay, and divide that by 2.00 into 10 to the power 2 grams, or you can also make it that also means, so 2.00 into 10 to the power 2 grams means 200. This can also be written, so best is to just put it in that way, it's easier. So 200 grams. So this is the solute and this is the solution. Okay, and here this is the solution times 100%. Okay, and what do you get here? You get 15.8 divided by 200 times 100, and that gives you 7.9% mass by mass percent. Okay, and that's the answer. So the answer is mass by mass percent is equal to 7.90%. I mean, 2 places after the decimal. So that's the answer. All right, that thing. Now let's look at the next one. Here you are going to find the molarity. Okay, you're given the grams of a substance, which is C6H12O6, and we need to find the molarity of this. So what are we going to do here? So here molarity, always write the the units. Okay, write down the units. So units are, one second, the formula, molarity is equal to moles over liters, the volume in liters. So what are the moles? The moles of the solute. Okay, so these are the moles of the solute moles, always in less amount, over the volume of the solution in liters, always. Okay, now if you're given in grams, you need to convert to moles. So 66.2 grams of C6H12O6 times 1 mole of C6H12O6, right? Divide that by the molar mass. So the molar mass you can calculate on the side, and I'm going to get this here. The molar mass of C6H12O6 is equal to, I think it's 180. C6H12O is 180.16 grams per mole. Okay, so this is 180 grams of C6H12O6. Okay, so here you have 66.2 times 1 divided by 180. And this gives you 0.367 moles, 3 significant figures. So this is the moles. Okay. Another thing that you're going to do is you're going to convert the milliliters to liters. So we know that 1 liter is equal to 1000 milliliters. So you're going to convert this into liters and you're going to convert this into moles. So this is what I have done. So here you are 235 milliliters. Okay, times 1 liter over 1000 milliliters. Okay, so 235 divided by 1000 is equal to 0.235 liters. Okay, so in this case, as you have seen, when you set up these problems, grams and grams cancel out, milliliters and milliliters cancel out, and you're left with the units that you want, which is the moles in one case and the liters in another. Next is find the molarity. So molarity is equal to moles per liter. So molarity is 0.367 moles. Okay, divide that by 0.367 moles, divide that by 0.235 liters. Okay, so 0.367, divide that by 0.235, and that gives you 1.56 molar. So if one of the choices is 1.57, that's okay. But in this case, as you can see, this is the answer. Okay, so this is the molarity. Okay, and that's the answer. All right, so this is the way you are going to do. Next is using concentration as a conversion factor. Okay, you're given the moles, you're given the molarity, find the volume. Okay, so all right, so here molarity, so write down the formula here. Molarity is equal to moles of the solute over the volume of the solution in liters. Okay, so molarity is given, moles is given. So we will just have to, this is just basically oh, what they mean is using conversion factor. Okay, here you're going to use this volume. We need to find the volume. Well, I don't understand. So here we can just simply do this from this here. Volume in liters is equal to moles over molarity. All right, volume. Yeah, that's the other formula. And if we were to find the moles, moles is equal to molarity times the volume. These are the three arrangements, okay? So anyway, it doesn't matter. So volume in liters is equal to moles is 0.0773. 0.0773. Okay, moles divide by the molarity, which is 0.0444 m. So 0.0773, divide that by 0.0444, and you get 1 point, volume in liters is equal to 1.74 liters, and that is the answer. So always just make sure that you always write the units and what is it we were trying to accomplish. Okay, next is you're given the mass, you're given the volume, and you're given the molarity. Okay, so what is that? No, you need to find the mass, okay? So here, what is the strategy? We know we are given the molarity. We know molarity is equal to moles over the volume in liters. Okay, so this is what we know. So using this, you can find the moles. Moles is equal to molarity times the volume in liters. This is given. Okay, molarity and volume is given. You can find the moles. Next thing is you're going to convert the moles to grams. And how will you use that? Using the molar mass. Okay, so this is the strategy you're going to follow. And the question is asking how many grams, and we are looking at sulfuric acid. So let's do this first. So first step, find the number of moles. So moles of H2SO4 is equal to molarity of H2SO4 times the volume. Molarity is 0.0578 m times the volume is 1.08 liters. So let's do this. 0.0578 times 1.08, and that gives you, this is equal to 0.0624. Three significant figures, so 0.0624, that is the number of moles of H2SO4. Next, you're going to take the moles of H2SO4 and convert them to volume, convert them to the grams. So moles to grams. So here we have the H2SO4, and you can do this on the side. H2SO4 molar mass. The molar mass of H2SO4 is molar mass of H2SO4, H2SO4 molar mass is 98.07, 98.07 grams per mole. Okay, so now we have 0.0624 moles of H2SO4, okay, times grams, 98.07 grams of H2SO4. Divide that by 1 mole of H2SO4. Okay, so here moles of H2SO4 cancel out, right? And you're just left with the grams. So let's get this. We have 0.0624 times 98.07, right? And that gives you 6.11. This is equal to 6.11 grams, 6.119. So actually this becomes 6.12 grams of H2SO4, and that is the answer. Okay, so just highlight this, and this is how you will do. So 2 steps. Okay, so this looks like this is going to be like, this is kind of like a test question. Okay, this is like if we were to give you some question, this would be one of the questions of choice. Okay, because we can test a lot of things here. We can test whether you know how to check the molar mass, whether you know how to do these conversions in the formula, get the things from there, right? Whether you know how to get the moles and convert the moles to grams and grams to moles, those things, everything like that. Okay, multiple things can be tested. All right, here we have another question which is based on dilution. Now, dilution is where you add water to a stock solution, certain amount of stock solution, and you add certain amount of water to make a solution with less concentration, and that is the dilution. So this dilution formula is M1, it can also be C1, M1 V1 is equal to M2 V2. So if C1 means that the concentration can also be parts per million, concentration can also be, mass by mass percent, excuse me, volume by volume percent, and so forth. Okay. So here's the dilution. In this case, we need to find V2. So set this problem up, and we are given milliliters and molarities, so the units are all the same. So M1, V1, excuse me, over M2 is equal to V2. So now we have V2 is equal to M1. M1 V1 over M2. So just put in the numbers here. Okay, so this is the KBR solution. Okay. Oh, let's see. So here you are 0.885 M times 76.5 milliliter. Ideally, this should be converted to liter, but because both the units are in milliliter, they'll cancel out. Okay, over M2, which is 0.500 M. So let's see. So 0.885 times 76.5, divide that by 0.500, and you get 135. So this is equal to 135.40 milliliters. Okay, so here you see the unit of M and M cancel, and you're just left with the units, because this is, like I said, this is in milliliters, this is in. So ideally convert milliliters to liters. Okay, ideally, but because they are the same, so that's why we left it as same. Okay, but so because the answer is in milliliters. Okay, so this is the answer. Now here's something you remember. M1 could be a bigger number, but the volume is small, and M2 will have to be small then, and the volume would be a bigger number. So you see here that when the molarity was higher, 0.885, we used 76.5 we used 76.5 ml, right? But when the molarity went down, became 0.5, then the value of the volume increased. So this is how you check whether you got the right answer or not. So when the molarity goes down, the volume goes up, and when the molarity is lower, the molarity is higher, the volume is lower. Okay. All right. Next is we have these 3 more small questions to do. Okay, here we are given the oh, this seems like it's a titration question. Okay, so here we are given this reaction. So here lithium hydroxide is a base reacting with H2SO4, which is an acid, and you are getting lithium sulfate, Li2SO4 plus H2O. So this is a neutralization reaction. Recognize a base, and I'm showing that base as B here in the like little subscript, and this is acid, and I'm showing it as A. Okay. So balance, so this is 2, and so there are, so this becomes 2. So 4 hydrogens, 1 sulfate, 2 lithiums, and 2 oxygens. Okay, so that's balanced. Now, this is the strategy you will follow. First, we need to, so the question is asking you how much of the base, the volume of the base is something that we need to find. So we are given, so here we are given the, so we know, first of all, find the moles. Moles, I'm showing moles as N. Okay, so N moles of acid is equal to the molarity of acid times the volume of acid. Okay. Second thing is, once you get the moles of acid, you can find the moles of moles of base. How? You take the moles of acid times the mole to mole ratio from the balanced equation. From balanced equation, you take the moles of base on the top and moles of acid. So from the mole to mole ratio. So you get the moles of the base. The third step is you take the moles of the base. Okay. So we know that the molarity is equal to, we need to find the volume, right? So moles of the base over the we need to find a molarity, a given molarity of the base, and you are going to get the volume of the base. Okay, so this is the set of conversions or the steps. So first step, obviously, write the balanced equation, always balanced equation. Without that, the whole equation, you won't get any points if you don't do that. Okay, so first is the molarity of the acid, sorry, the moles of the acid. So you are given 0.250 m times the volume is liter, 0.500 liter. If the volume is given in milliliter, always convert, let me put this here, can always convert, because in the labs, right, we use the milliliters. Always convert volume from milliliters to liters. That's something you always do on the side in this case. All right, anyway, so we have 0.250 times 0.50. So 0.250 times 0.500, and you get here, this is equal to 0.125 moles. So these are the moles of the acid, which is the H2SO4 acid. All right, next is the moles of the base. So how do you do that? You take the moles of the acid, which is 0.125, okay, moles of H2SO4. Let's write this down, H2SO4 times the mole to mole ratio. So we see that from this equation, 1 mole of acid, 1 mole of H2SO4, 1 mole of H2SO4 is reacting with 2 moles of H2, mole to moles of LiOH. Okay, and what do you get here? 0.125 times 2 divided by 1, and you get this is equal to 0.250 moles. And these are the moles of lithium OH, lithium hydroxide. Okay, next is we need to find the volume. Okay, so the volume of lithium hydroxide in liters is equal to the moles of LiOH, which you calculated on the top, over the molarity of LiOH. So just put this thing here. Moles are 0.250 moles, okay, over the molarity is 0.250, it's coming out to be 1. It's not, the answer is not matching. Wait a minute, let me just check one thing. Give me 1 second. Okay, so the molarity of LiOH is 0.250. Okay, so this here you are given the molarity, the moles. over the molarity. So here is the molarity M. And so that gives you the volume. So that it comes out to be 1.0 liter. But for some reason, I checked everything. The answer in the book seems to be wrong. Okay, so this seems to, by this calculation, this is the right answer. So the volume would be using 1.0 liters. Okay, and that is for the lithium hydroxide, LiOH. Okay, yeah, okay. Anyway, so that is the answer. Okay, so but the answer listed from the book seems to be incorrect. I don't know, maybe it's a error or something. I double checked everything. So anyways, all right, next is the very interesting. This is the colligative property. So here we are given this formula, or you should know the change in boiling point. This is the change in boiling point of the solvent when a certain amount of solute is added. So here you are given 10 grams of the acid, 10 grams of the salt, NaCl, and you're adding it to water, 100 grams of water, okay? We need to find what is the final boiling point. So delta T is a change, the change, delta TB is a change. What is the final? The final boiling point is always going to be the final boiling point is the one second, is the initial, okay, here's something. So this delta TB stands for, delta TB also stands for T final minus the T initial. And always remember that the initial for, in case of water, is going to be 100 degrees Celsius. So in other words, what is the final? T final, the final boiling point becomes the initial, the change in the boiling point plus the T initial. Okay, then that's how you get. All right, so now we are going to, this piece is kind of known. Ideally, I write all this in red, but anyway, so let's do this. All right, so here is first, let's find so we are given the mass of sodium chloride and the mass of water, 100 grams. We need to find the final temperature. The value of Kb is known, which is 0.52. This is the ebullioscopic constant of water, and that is degrees Celsius over molality. So molality is the moles of the solute over the kilograms of the solvent. Okay, so, and the value. So delta TB, and for NaCl, NaCl, because Na can give you sodium and chloride ions, therefore the value of I is equal to 2. Okay, now TB, this is the solvent, this is the solute, and this is the solvent. So 100 grams, so convert, so here we need to convert the grams of NaCl to moles of NaCl, because that's what you need to put in the molality, okay? Moles of NaCl. And you're going to convert the 100 grams to kilograms, okay? So let's do this. NaCl is 23, so molar mass of NaCl is 23 plus, sorry, 23 plus is 35 is 58.44. So here you have 10 grams NaCl times 1 mole of NaCl over 58 grams. So this becomes 10 divided by 58.44, and that gives you 0. So the moles of NaCl is moles of NaCl is equal to 0.171 moles. So that's one thing. Next is the volume mass. So the mass of water. So the mass of water from grams to kilograms. That's what we need. Okay, to satisfy the molality. So here we have 100 grams of water, right, times 1 kilogram over 1000 grams. So 100 divided by 1000 and you get 0. So this is equal to 0.100 kilograms. Okay, so these are, let's put here. So we need the mass of water in kilograms. Sorry, this is the, which is the solvent. So mass of water in kilograms. And then we have the moles of the solute, NaCl. Okay, the mass of water in kilograms. Okay, now the rest is we are going to just put in the numbers. So let's put it here. Sorry, let's do this here. Delta TB is equal to, the formula is I times KB times molality, M dash. So delta TB is equal to 2 times 0.52. 0.52 degrees Celsius, right, per degree Celsius times kilograms per moles. Okay, times now M dash. M dash is the number of moles of the solute over kilograms of the solvent. So moles of the solute is 0.71 moles, and that is for NaCl. Why am I doing it here? I'm sorry. Let me just move all of it. There's lack of space. Okay, let's make all of this small because it's occupying too much space. And then all right, here. And then this thing also small. And the main thing is this piece. All right. Okay, now we have this. All right, now let's do this. Delta TB is equal to 2 times 0.52 degree Celsius kilograms per mole times the moles of NaCl was 0.171 moles, and that is for NaCl. Divide that by the kilograms. So 0.100 kilograms of water. Okay, so what do you have here? We will see that the kilograms and kilograms cancel out, moles and moles cancel out. Okay, and you're just left with the unit of degrees Celsius. So now let's do this. 2 times 0.52 times 0.171, divide that by 0.100, and that gives you the change in temperature is, the change in temperature, the delta TB is equal to 1.7784, and this you can make it as 1.78 degrees Celsius. So this is the change, but we remember T final is the initial boiling point of water is 100. So 100 plus 1.78 degrees Celsius. And what do you get here? So you have 101.78 degrees Celsius. This is the value of the T final, and that is the answer. Okay, so a little bit, this is how you do it. Okay, so there's going to be a question on the exam, and we will be giving you the KB value. So don't worry about that, but you should know the initial temperature, the boiling point of water is always 100. Okay, now this is an osmotic pressure. I did not include that, but you can calculate this. This is based on this formula, pi, or I don't know what this is called, but M R T. Okay, so molarity is given. So here the question is asking you, what is the osmotic pressure? So take the molarity 0.33 m times R is 0.08206 liters atmosphere per mole K. And the temperature given is 25 degrees Celsius, but you need to convert it into Kelvin. So you're going to take 273 plus 25, and that gives you 298K. So 298K. So here we have 0.33 times 0.08206 times 298, and you're getting 8 point. The answer for this is, it's actually not pi, it's a different name is different. Osmotic pressure. So the osmotic pressure is equal to coming out to be 8.06. So I am having 8.0697 whatever. So you can also get it as 8.07, and the units for this one then is osmotic pressure, no, at ATM. Because if you look at it, the ATM moles, so molarity is moles and liter, moles per liter, that's cancelled. K and K is cancelled. So you're only left with the units for ATM, and that is the answer. All right, so this finishes this thing. So you can always use these type of questions for review on the exam. And I hope this was helpful. Thank you. Thanks for watching.